Unlike other compressor models, our dynamic compressor model contains a momentum balance which accounts for surge behavior. This model encompasses not only the normal operating range to the right of the surge point, but also includes the negative branch of flow to the left of the surge point. Few simulations include the effects of this branch. The operating point walks along the negative sloping compressor characteristic curve from point A to B but then jumps from point B to C as a result of the positive slope. The operating point then walks along the negative sloping characteristic curve from point C to D but then jumps from point D to A as a result of the positive slope. The whole cycle then repeats itself if the surge valve is not opened far enough. The actual jumps in flow are only seen by a very fast flow measurement with extreme rangeability and ability to sense negative flows. A dynamic surge simulation enables the user an offline automation system to see the extremely disruptive jumps in flow from the positive feedback of the positive slope of the characteristic curve. We have put a simplified demonstration together to show both the simplified version of the control strategy and the dynamics possible. The system is comprised of an upstream header, a plenum volume just downstream of the compressor, and a surge line recycled through a heat exchanger. For this system, the downstream disturbances are induced through adjusting the throttle valve position, but they can also be induced by altering the pressure upstream or downstream of the compressor. We will now demonstrate how the system can model surge. For this part of the demonstration, the open-loop backup has been disabled. This shows what would happen in a real plant's compressor without an anti-surge controller. We can open the trend view to show what the surge oscillations look like. We can get a rough idea of what the characteristic oscillation of surge looks like here. The resolution from trend view is such the sum of the shape cannot be resolved. The actual model is running at a 50 milliseconds execution time while the trend view is only able to resolve at 100 milliseconds. By re-enabling the open-loop backup, the PI block is placed in or out, and the system exits surge by ramping the surge valve at a user-configured rate for 10 seconds, then returns the PI block to auto. Our control strategy consists of two major components, preemptive backup and closed-loop control based upon a future value. We begin by computing an approximate compressor suction flow value 2 seconds into the future using Mimic's future value block. The surge set point is computed from the pressure rise on a compressor map as a curve for minimum suction flow offset to the right of the actual surge curve. Points on the actual surge curve identified by the detection of a near-zero slope by the future value block can be analyzed and cautiously used to update the actual surge curve online. The near-zero slope would be the result of the future value block reporting a near-zero change in pressure rise for a significant change in suction flow. Changes in operating conditions and compressor characteristic curves over time can cause changes in the actual surge curve. This control strategy also contains logic to detect imminent surge. Whenever the predicted suction flow value is below the unmodified set point, or if the derivative exceeds a critical negative value, a flag gets set triggering the open-loop backup for 10 seconds. Once the open-loop backup is cleared, the PI controller transitions from R-out to auto. Another key factor in systems with surge are the valve dynamics. Often, valves are the slowest responding elements in a compressor system, which makes their dynamic simulation essential for surge processes. To include valve dynamics for the surge valve, we have simulated a quick opening valve with a dead time of 0.4 seconds, an opening slew rate of 50% per second, and a closing slew rate of 5% per second. Additionally, the backlash stiction block includes two-stroke lag times of 0.4 seconds and 0.1 seconds. The output of the backlash stiction block is connected to the surge controller's backcalculate input, thereby linking valve dynamics and control performance.